Okay.
Go ahead.
So, Lionel, can you see my slides? Okay.
Yes, I can. You look great.
Great. Okay. Thank you, Mark. So yes, today we're going to talk about industrial surface coating, VOC and HAP regulations. So when I refer to industrial surface coatings, what I mean is original equipment manufacturing or factory applied coatings. So for example, a brand new car that's coated in the factory, that's what we're talking about, as opposed to architectural where it's applied in the field. Applicability, these tend to, I'm going to get into a little bit more later on, but there tends to be applicability limits in many of these VOC and HAP regulations. In general, is not not every application facility is subject to the rules. There tends to be some kind of a threshold, and I'll go over that as we get into it. And I think it's important to recognize that many of these surface coating rules, there's usually two options. You can either the facility can use a compliant coating that essentially meets the VOC or HAP regulations or standards, or the facility could, for example, have add-on controls, and then they wouldn't have to. They could, pretty much use any type of coatings that they want to, as long as they're capturing and controlling those emissions. And then, in general, so the American Coatings Association, we are a trade organization that represents the coating manufacturers. So in general, application facilities out there, usually you can contact a coating manufacturer. They will likely have a compliant coating. They can help you, if we have application facilities on the line today, they should be able to help you, find a compliant coating or deal with, regulatory issues. So let's start with a volatile organic compound or VOC regulations. And I think it's important to, a major driver for VOC regulations is the National Ozone Standard. And a little background here is that the Federal Environmental Protection Agency, under the Clean Air Act, is required to review the National Ozone Standard every 5 years to see if it's protective of human health in the environment. It's been modified a number of times over the years. Back in, for example, 2008, EPA lowered it to 0.075 parts per million. October 2015, it was lowered again to 0.07 part per million. The reason I'm mentioning this in the slides is that, again, it's a driver. The states have to comply with the National Ozone Standard. They have to come up with, their state implementation plans. They have to essentially tell EPA, how they're going to try to, come into attainment for ozone. And typically, if they're not in attainment or a non-attainment status, what happens is they look for, either, nitrogen oxide or VOC reductions. And for our industry, the coating industry, because of, we do have VOC emissions, we tend to be, or our industry tends to be, one of the first industries that states go after to try to get VOC reductions. So with the most recent lowering of the ozone standard, here's just a map of the United States. The takeaway from this slide is that we all know that California, with the 35 air districts out there, they've had regulations on the books for many, many years. The Northeast, from say Maine to Virginia, comprised of the Ozone Transport Commission states, they've had regulations for many years. It's the areas that I've circled that, because of the new ozone standard, will probably adopt more stringent regulations, from a coatings perspective. The Utahs, Colorado, Nevada, Louisiana, Georgia, Michigan, Wisconsin. Those are going to be, some of the more, Minnesota, again, states that in the future will probably do more stringent standards. But I'll get into that shortly. Okay, so what happens? EPA develops something called a Control Technique Guideline, or a CTG, And these are model regulations or guidelines that states that need further reductions, VOC reductions. The states can look to these guidelines to as they develop their standards. The benefit from industry's perspective is that hopefully the states are consistent in what they come up with, be it definition, applicability, VOC limits. So at least we hope that if states move forward, they try to stick to those CTGs to the extent they can to give it, again, clarity and consistency across the U.S. These CTGs are typically based on what happens in California, be it the South Coast Air Quality Management District or Bay Area. And the CTGs are developed across multiple substrates. For example, there is a miscellaneous metal and plastic parts CTG, auto and light duty truck, all the way to, say, large appliance. So for the various substrates, there are these guidelines that states will use to adopt their standards. The second to the last bullet, Delaware through Vermont, these are many of the states recently that have adopted more stringent industrial surface coating regulations. And this list will probably get larger as time goes on, as more and more states try to come into compliance with the new ozone standard. And just a little bit more background. So in this slide, here's an example of miscellaneous metal parts. The applicability is essentially for a facility that uses more than 15 pounds per day of VOC. They would, or 2.7 tons per year. If that facility, meets that criteria, it would be subject to the rules. Facilities smaller than that would likely not be subject to the VOC limits in a state if they're following the EPA Control Technique Guideline. So EPA developed a CTG back in 1978. And here's just an example of what that looked like. They had an air dried category, 3.5 pounds per gallon, and a clear of 4.3 pounds per gallon. Moving to 2008, the most recent CTG, and let me just back up 1 second here. Back in 1978, there was 4 categories of coatings or limits. It's much more complicated today. In the 2008 CTG, there's 24 categories, and they're broken down into air dried and baked. Air dried would essentially be where the part is coated and essentially left to evaporate. Could be controlled, it may not be controlled. Whereas a baked would be a part that is coated and put into, say, an oven. And there are different limits for air dried and baked. For example, a general one component air dried is 2.8 pounds per gallon. So the limits have gone down, the number of categories have gone up, and it's bifurcated into air dried and baked. So I would say more complicated because we're moving into more categories, and depending on the facility, what it has, different limits apply. These CTGs also get into work practices. Beyond just the limits, they get into, for example, the type of guns that facility could use. The new CTG requires HVLP equivalent type of guns or application. So there's provisions that you'll see in there where, what type of guns the facility could use. Second, cleaning solvents. Some CTGs may get into the type of cleaning solvents or solvents that the substrate needs. Before you coat, you might wipe the substrate down. Sometimes there might be some discussions in these rules. However, there is a whole nother suite of regulations called industrial solvent cleaning regulations that states have been adopting over the last couple of years that will get into again, the solvents used to wipe down the substrate, the type of solvents that are used to clean out the spray guns, et cetera, et cetera. And those could be you know, 50 gram per liter. They could have a certain vapor pressure requirement. So just want to throw that out there, that the type of cleaning solvents that are used in facilities could be regulated as well. And then finally, the CTGs tend to have a higher control requirement for add-on controls. For this one here, the miscellaneous metal parts, it's 90% control. As far as a couple other issues here, the CTGs tend to point to a test method. That would be EPA method 24. Actually, it's the oven method. You weigh a sample, you put it into an oven for an hour, you then weigh the sample again, and then, you know, what essentially leaves is essentially a VOC, water, and or an exempt compound. EPA in the CTGs, they essentially, you know, point to the test method, but they also put in there that a application facility can use a coating manufacturing formulation data as an alternative. So information that a facility might receive from a coating manufacturer, be it a safety data sheet, a product data sheet, environmental data, that can be used for compliance in general. But typically what happens if there's, you know, many of the rules will say that if there's a disagreement between the information coming from the coating manufacturer and testing that, say, a state might do, then usually it's the state testing information that supersedes, or that maybe the coating manufacturer might have some test data that they can provide. So there's usually, the application facility, or EPA says that the application facility can use formulation data from the coating manufacturer, but there are stipulations that you know, typically the test data would supersede in say an inspection or enforcement situation. So I'd mentioned earlier about the applicability. We are starting to see states that are starting to change or move away from the suggested applicability coming from EPA. As I mentioned, it was 15 pounds per day, 2.7 tons per year of VOC before you become subject to these regulations. I did want to mention that in Utah has some severe issues with PM 2.5 and ozone, and they lowered the threshold. For example, instead of being 2.7 tons per year, they went down to 20 gallons of coating use per year. So pretty much every facility in Utah is subject to the limits out there. We don't agree with that. We believe that, at least from an association perspective, there should be a bright line, a reasonable bright line. Facilities that are using, quite a bit of, coating could be subject to the rule, but there should be a reasonable threshold, and we don't believe the Utah threshold was reasonable. Okay, I had mentioned earlier that many of these CTGs are based on California. I did want to let everybody know that if you have any kind of operations, the South Coast Air Quality Management District or South Coast, they intend to work on several of their regulations in the future. Marine coatings, aerospace, metal parts, wood products, and their solvent cleaning operations. It's likely that when South Coast does do work on these rules, they may look at any kind of an exemption. They may look at the applicability, as we've been discussing, possibly lower limits. I'm going to mention this a new method in a minute, but instead of using method 24, South Coast has a new, I'll go to it right now. South Coast has a new VOC test method. It's their, they call it their South Coast method 313, and there's a associated ASTM method, D6886. These are gas chromatograph methods. You have instrument, you inject the coating into the instrument, on a computer screen, you'll see all these various blips that come up on the screen, and then you essentially add up all the peaks that come across from the machine, and that's how they essentially a direct measurement of the VOC. In the past, there have been criticism with EPA method 24. When you get down to very, very low VOC coatings, you could actually get a negative number. So the new methods, South Coast method 313 and ASTM D6886, they are better looking at waterborne or low VOC coatings. There is a problem, though, at least from our perspective. South Coast method, we believe, redefines what VOC is. They have a VOC marker, and that marker is methyl palmitate. I think it has a boiling temperature of up in the 300 degrees Celsius. So the problem, and the way it works is that when they go to test a coating, they put that marker into the coating, and when methyl palmitate comes up, the peak for methyl palmitate comes up. Anything before that peak would be a VOC. Anything after that that peak would not. So essentially, it's a marker. So you can decide what is and what is not a VOC. The problem is that methyl palmitate is it essentially is a semi-volatile, high boiler. So there could be a situation where a difference between method 24 formulation data and method 313. We think that this test method is moving. It's currently in South Coast. South Coast intends to, as they open up their various surface coating rules in the future, they'll probably drop this test method in there. And it's likely to spread to other states when they do that. So eventually we're going to see these other methods pop up elsewhere in the United States. Highly recommend if you're worried about this, maybe run a D6886 method. You can't really find a lab that will run the South Coast method 313, but you can find labs out there that run the other alternative method. And then they can just drop in that methyl palmitate marker, and you essentially get a surrogate for what it would look like. But I highly recommend it because there could be some big discrepancies between the current method and the new methods. It's probably a good time to talk about exempts. Exempt compounds are essentially a volatile organic compound, but EPA has determined that certain volatile organic compounds don't really contribute to the formation of ozone. And if it's an exempt compound, you don't have to count that towards your VOC content of the coating. A couple that, acetone, for example, or methyl acetate are just examples of some exempt compounds. The problem is that even though EPA designates or comes up with a list of exempt compounds, many of the states have to incorporate those exempt compounds into their rules. Some are directly reference the EPA list. Some have to essentially change the regulation every time EPA makes a change to their exempt compound list. So you can't assume that just because EPA has an exempt compound out there like acetone or methyl acetate or others, that would be essentially exempt, say, in a California air district. And that's the issue. Really, in some of the California air districts like Bay Area, Sacramento, South Coast, Los Angeles, many of these districts have not adopted the exempt compounds from EPA over health concerns, for example. TBAC, tertiary butyl acetate, for example, is a federally exempt compound, but many of the California air districts have not exempted TBAC. PCBTF or oxol. Just want to give everybody a heads up that it looks like the National Toxicological Program, NTP, came out with a report that it's likely that oxol or PCBTF is probably a carcinogen. That will eventually be published in their annual report on carcinogens in the future. But you know, there's an example of another exempt that's widely used that you know, could be problematic in the future. So bottom line on this one, takeaway: there are exempt compounds out there. They're not exempt throughout the entire United States, and it's not a static list. It could change, either not exempted or those exempts could change over time. So it's important to keep an eye on that. So let's move on to a subset of VOCs, which are HAPs. HAPs are hazardous air pollutants. I think this is what, 187 or 189 VOCs are HAPs, and these are compounds that have you know, EPA has designated as being, or others have designated as being toxic or, you know, problematic. So if these rules apply to very large sources or application facilities, I'm thinking, you know, just throw a couple of names out there like General Motors or Ford or, you know, John Deere. I mean, these very, very large facilities that use, you know, a lot of coatings. You have to be subject to these rules, it has to be 10 tons of a single HAP, 25 tons combined of, you know, various HAPs. But I want to bring to your attention that back between 1995 and 2004, EPA developed all these surface coating MACT rules that I've listed, everything from shipbuilding and repair to plastic parts and products. So many times you'll get questions about VOC content, but then you may also get, you know, what is the HAP content as well, and that's what they're referring to, are these rules, or many times what they're referring to. And the reason I mention it today is that EPA is required under the Clean Air Act to look at these. Bear with me one second. EPA is required to review these MACT standards 8 years after they've been promulgated, again, to see if they need to be more stringent. And the way they do that is a multi procedure. So one is a residual risk. What they do is the EPA will model downwind receptors or neighbors to a application facility, and see if you know, the receptors are being impacted by the type of you know, HAPs that are coming from that facility. If EPA does find that there's some kind of a residual risk, they could make the standards more stringent from that perspective. The second stage is technology review, and EPA will look at have there been any new technology adopted by the industry, spray guns, new add-on controls, new types of coatings. And if EPA can cost justify, you know, essentially new technology, that could be a second pathway to make standards more stringent. And then finally, they can set additional MACT standards for sources that aren't regulated or that were, you know, potentially exempted from the original rules. So EPA has completed 3 RTRs so far: shipbuilding and repair, wood furniture, and aerospace. Shipbuilding, no changes. Wood furniture, they included a formaldehyde limit, and then in the aerosol MACT standard, EPA added a bunch of VOC standards and limits for 55 specialty categories. So here is the schedule. If you're interested, of EPA was sued and essentially has to is required to complete these rules by a certain date, and I've listed them here. You know, big ones, you know, metal can and coil, auto and light duty truck, miscellaneous metal parts, plastics parts. Those we'll probably see next year, but you know, EPA is under a pretty stringent requirement to get these completed. So if you do have or if you have anything to do with these various industries, something to keep an eye on. So, and finally, what will these rules look like, or these RTRs? So far, I haven't seen too many of these rules where they've lowered the HAP limits. They tend to find that so far many of these rules, they've been from a residual risk. They are stringent. You saw the slide earlier. EPA did change a couple, added on a couple additional requirements, but looking at it right now, I don't see too many of those rules lowering the HAP limits, but I think what the EPA will do is probably prohibit the use of conventional spray guns, or will require the use of more effective or efficient spray gun technology, kind of like the VOC rules that I mentioned earlier. There's luckily EPA will increase the monitoring on add-on controls, and then because of another lawsuit, EPA is essentially requiring these facilities that they have to be compliant 100% of the time. Meaning there used to be provisions in many of these rules that during the periods of startup, shutdown, and malfunction, there was essentially an exemption or a provisions where the facility could do the best they could, but they didn't necessarily have to meet the control requirements during those again startup, shutdown, malfunction. Because of a lawsuit, the facility, that provision has gone away. So bottom line is, application facilities that are running add-on controls, 100% of the time, that facility needs to meet those requirements. So that definitely adds stringency to these rules and is problematic. It's hard, for some facilities to reach that standard. Okay, and then I know I went through a lot of material here today, but I'm looking forward to answering any questions, but here are my details. If you do have any questions on various VOC or HAP regulations, feel free to reach out to me and I'll do my best to answer any questions that you might have. Lionel, if you can open it up for questions, or Mark.
Oh, absolutely. I'll just unmute all and
I found a way to numerically see. There was that one question. Okay, question 6 is you either have to say very effective, not effective, or somewhat effective. I just assigned a numerical number to those, so that way it was easy.
okay, I think that was some other question from you. That sound right at all? Hello?
Hi.
Hi. Okay, I was going to unmute everyone, but it seems like some people might be on other conversations, so I'll let people unmute themselves if they have questions.
So Mark, I know that one question that we were kind of kicking around earlier while people are getting ready to unmute. I tried to address the question earlier about can application facilities use coating manufacturing information like safety data sheets and product data sheets? That's my understanding. If they can't right now, I know that the EPA recommendations through the CTGs, that was the recommendation to the states to allow the facilities to use the coating manufacturing data. Again, if it comes down to enforcement, the test method would supersede. But in general, that we're hoping that kind of meet. Facilities can use the information from the coating manufacturer to essentially meet their compliance requirements.
David, what I encounter is maybe very small businesses that perhaps they buy the various ingredients and then they mix it. So they may have the as supplied safety data sheets, and they may be a little bit confused as once they mix it up, what the VOC content is as applied. And then sometimes the safety data sheets will make reference to the regulatory VOC and then the actual or total VOC, which I think confounds businesses, say like, well, very small businesses like body shops.
Right. Right. Good question. Yeah, you definitely got into the complexity of it real quick here. So yeah, absolutely. I mean, many of these, you in your product data sheet, for example, depending upon if that coating is going to be thinned or not, there are going to be. I would think that many manufacturers would give the instructions to the applicator as far as how that coating is to be applied, what type of solvent is to be used, what ratios, etc., to still be in compliance. And then maybe to your second point is that bottom line, reach out to the coating manufacturer if there's a question. I would think that they would be able to help. And then to your second question about material versus regulatory, it gets complicated. So just a little background here. So the actual VOC, material VOC, is essentially if you add up all the VOCs in a coating, that's what that would be. But if you go into the rules, there's a calculation in the rules to come up with the regulatory VOC content. If people have heard the terminology less water, less exempts, because
right, yeah.
So it is complicated. I'm glad you mentioned that. But again, work with your coating manufacturer where you get the product. They should be able to help you get through that. If you have a question, you can send something to me. But yeah, if they're mixing their own without following what's coming from the manufacturer, that's a tough one. Again, most manufacturers will put on their safety especially their product data sheet, some of those recommendations. Does that help at all?
Yes, I am kind of curious with respect to the new ozone standards. Do you see any of the limits in pounds of VOC per gallon of coating, less water or exempt solvents going down? Because I know some of the issues like miscellaneous metals for VOCs, I don't know if that's a generic 3.5, but some companies seem to have an issue with meeting that 3.5. I don't know if they're just afraid of asking their coating manufacturer if they can supply them with a coating material that's 3.5 or less. But some of them claim they have to use something greater than 3.5.
Yeah, good question. So on that slide that I mentioned earlier, so here, tell you what, if I can go back without causing.
So I don't know if you know if that number is going to go down or not.
Definitely.
3.5.
Oh yeah, because that was so the 3.5 was based on the air dried was based on the 1978 CTG. Due 2008, and again, it has to be in the state that's updating their standards. I provided in the other slide. Where was it? Back here. Bear with me. Second to last bullet here. Delaware through Vermont. Many of these states have already updated their VOC standards, and so that 3.5 air dried was just a general category. There's now 24 categories, both air dried and baked. The air dried is going down to 2.8 pound per gallon for like a general one component, for example. So yeah, many of those older limits have gone down in those states that I mentioned. But I would be definitely reach out to the coating manufacturer. They should be able to provide a coating that can meet the limits. May be problematic. It might be different technology. They might have to kind of work through the application and stuff like that. But the coating manufacturer should have coatings that meet the new limits.
So would that mean greater solids content, perhaps, or just less VOC?
Correct. It could be greater solids. It could be exempt compounds. It could be waterborne technology. Any of the three. Could be really pushing out there. Powder coatings, for example. But there are other technologies. It's just a matter of reaching out to the coating manufacturers. Working through. There probably are going to be slight differences in how those products are applied, the type of equipment. Unfortunately, that's the problem with lowering these limits. Things change, and you just have to kind of work through it and to get the product you need and get the performance you're looking for.
Now, do you see coating manufacturers trying to reformulate their coating materials using VOC exempt compounds?
It all depends. Again, that's one route or that's one pathway. Some move down to waterborne technology. Some do high solids. Some, there's other technologies out there. Powder coatings, for example. So it all depends. Many of the coating manufacturers may have multiple pathways to help a customer get there. Be it exempt compounds or waterborne or something like that. So they should be able to come up with something to help the applicator.
I feel like I'm monopolizing your time, so
okay.
I'm hoping someone else is going to ask questions.
I did have one. Would you talk a little bit about the test methodology and how expensive that is for folks to do any of these test methods, have them run on their paints and coatings?
Yep. So I think method 24, let me start with, as I kind of mentioned before, my understanding is that applicators can use the information that they're getting from the coating manufacturers to comply. If there's ever a need for testing, most of the standards, most of the regulations out there point back to method 24. I think it's in the range of a couple $100, $250, $300 to get that done. Many facilities might actually have the equipment to do that in larger facilities. The new gas chromatograph test method that I talked about in California, I think that might be a little bit more expensive, maybe up into the $400 to $500 range. That may have changed though, because many more companies are actually running that test method. But we're talking a couple $100 to say $500 per test method in general.
Well, I guess if you're running up real close to the limit, it's probably worth it for those folks.
Because of enforcement. Correct. Especially, especially in California, a state or Los Angeles. They do a lot of enforcement. So if anybody's selling into California, Ohio, the Midwest states, Indiana, of course, New York, the Northeast, Midwest, and California, definitely a lot of enforcement, a lot of inspections. So yeah, if you're close to the limit, you're not quite sure you're there, it might be a good thing to do some testing.
Thank you.
Go ahead.
No, I'm done asking questions. You can go ahead, Mark.
David, I'm not certain if any of your coating materials are reactive coatings where part of your VOC is actually going to form some type of polymer. So is there confusion, or has there been confusion on how much of VOC is actually liberated versus how much is actually bound up in the coating material because there's a reaction that takes place?
Yep. Good question. So I know that, let's see, I'm trying to think. I know in many of the California rules, and for example, like the architectural, we're talking industrial right now, but I know in some of the architectural rules, for example, when they define VOC, they mention that if there's anything generated from the coating, that needs to be counted towards the VOC content. Off the top of my head, I can't remember in this suite of regulation. I would think in California, some of the regulations might actually say that. I'm not sure about the rest of the country, but yeah, you're starting to see the new suite of regulations starting to recognize that VOCs can be liberated or generated when you have a reaction. And the regulators are starting to recognize that, and you need to count that towards your VOC content. Again, that's more on the architectural side, and in some of the California Industrial Surface Coating Rules. I would believe it would be a trend in the future that there will be more recognition, because that's another one of the pathways to get to lower VOC content is reactive coatings.
Yeah. So you don't have the entire coating or the entire organic compound being liberated because it's
Right.
I don't know if it's a polymerization that's taking place, and I don't know what.
Yeah, I'm not a chemist. Yeah, not a chemist, so I think that's part of it. There could be several different types of. It has a lot to do with polymerization, but
there is confusion because people might start off with the starting point,
yep,
and then just assume all of it's being liberated, and don't fully understand that any of it is going to be bound up in the coating material, the coating solid.
Or the other way is that it may say X VOC content, but actually it is going to liberate some VOCs. It could go both ways. Again, maybe the suggestion is work with your. I would believe that the coating manufacturer hopefully will be provide that information in their product data sheets because of the regulations out there today. That would be my hope.
Yeah, I would hope so too. But generally, when there are questions by one state or maybe a few states, sometimes it's surprising how people view things as far as what is or what isn't going to be liberated. And the other part is actually the manufacturer and what they truly understand about the nature of the material they're using, other than they may know it's a reactive compound, and that may be it.
Yeah. Hey, I recognize that it's a complicated. That is a complicated issue. I think the regulators are coming on board. The new suites are probably going to start recognizing reactive compounds and VOCs, if that makes sense.
Yeah, and I'm wondering if some of those compounds are maybe more durable or longer lasting, which hopefully meant that you wouldn't have to paint as much.
I would think so. That's my understanding. That those, one of the pathways to lower VOCs or one of the pathways for new technologies is reactive. That's my understanding. That they tend to be much more durable, such as your epoxies and stuff like that.
Yeah. Well, again, I don't want to hog up your time. Certainly, there's got to be someone else who needs or has some dying or burning question they want to ask. Because this is a big issue. Is surface coating is, at least in Indiana, trying to help a business determine their potential to emit, which is very convoluted because, and I know this has come up in other states where they look at the spray gun application rate, or what you could do if you squeeze the gun open all the way and just wait 24/7. Others may just take it on, how fast are you going to, or how many parts per hour, and how many gallons per part. And then it's looking at, what kind of coating materials could you use? And so you could use anything under the sun, or you could say, we're only going to use these materials. So it becomes a very convoluted process, just doing that calculation, just to determine whether you need a permit or not, let alone whether you're subject to some type of VOC RACT rule or perhaps an NSPS or a HAP.
Definitely. Completely agree. The initial determination on potential is very, very critical because, if done one way, you could be subject to the rule. If done another way, maybe not so much. Extremely critical for an application facility.
Do you have any tools that you use to maybe help business or entities evaluate their potential emissions of VOCs or overspray or HAP?
Because our association really represents the coating manufacturer. It's probably more up to our members, the coating manufacturers, would probably help many of them, see it as a added service to help their customers, work through the permit conditions and stuff like that. So, no, I tend not to get involved with the applicators and what they're doing, but I know my members do. We run into the same situation with our coating manufacturing operations. I can say you can go to EPA has either the AP 42 factors or there's a Emissions Inventory Improvement Program, EIIP. There's a couple chapters on surface coating operations. I know several of the states and the California districts have guidelines or procedures and to help applicators figure out what emissions might be coming off, if that helps.
Yeah. So yeah, in Indiana, I think our permit writers use an Excel spreadsheet.
Yep.
And so we will generally provide a copy of that, but basically you have to plug in a number, and so it's broken down to something very generic, like parts per hour, but it doesn't really define. It could be big parts, small parts, or a mixture of those. And then you're trying to define the gallons per part, and then you're looking at what laundry list of coating materials you can use, and then you're adding density, weight percentages, et cetera, et cetera.
Right. I would hope that a coating manufacturer would be able to help the applicator work through some of that, or some of the details. I mean, that would be my hope. Or I would think that a customer, if they need help, they would reach out to and find a coating manufacturer that could help them through that.
I don't know what the latest and greatest is for coating application technology aside from HVLP or HVLP equivalent. But I mean, are the coating manufacturers the driving force behind application improvements, or are those the companies that actually make the coating application equipment?
I think it's probably more the latter. The companies that actually make the spray equipment that are probably driving that. And usually what happens is, new technology is found, and then the states or the district then, certify, and then that becomes a standard. So yeah, I believe it tends to be more the equipment gun manufacturers that are kind of driving that.
And I think California used to have a list of what they call HVLP equivalent, which might run the gamut of, I don't know what the typical HVLP equivalent efficiency is. I've heard anywhere from about 65 to 75%. Whether it's greater than that or not, I don't know. But I think some of the equivalents might even be more efficient than that.
Right. The rules they tend to be, if you go through the rules, they'll usually say use the following type of equipment. So they'll have like 5 or 6 bullets or more of types of guns that would be equivalent or be more efficient. Most of the rules have that.
Well, again, I could probably talk to you for quite a while, but I know that
Sure.
I appreciate you for being willing to develop this PowerPoint and talk to us. There is certainly a lot of room for talk and trying to better grasp what information we can use, because a lot of us are working with businesses in our states to help them kind of navigate through the various state and federal rules to know what they can do to get into compliance or to remain or stay compliant itself. So it's really a networking, and in your willingness to present and provide this information is certainly a benefit to us, because it empowers us to be able to go forth, knowing that maybe there are changes forthcoming, which might mean perhaps more changes to some of the state VOC rules itself.
Yeah, and again, if anybody has a question out there, feel free to send me an email. I'll do my best to try to steer you in the right direction.